Mixtures differ from compounds in various ways. A mixture is a substance which is made up of two or more different substances which are not chemically bonded together. Compounds are made up of two or more elements bonded together. This means mixtures are relatively easy to separate. However, because compounds contain bonds, they are more difficult to separate as chemical reactions are required. Mixtures also differ from compounds because they can have a random composition each time they are made up. Compounds, however, always have the same composition. Mixtures can be separated by a variety of different methods, depending on the physical properties of the mixture. Some of the simpler separation techniques include filtration, crystallization, and simple distillation. The more complex methods include fractional distillation and chromatography. In a mixture, some of the components may dissolve in one solvent, and other components may be insoluble in it. Insoluble substances would form an insoluble solid in a solution. An example of this would be to add water to a mixture containing tea granules and soil. The tea granules will dissolve in the water, but the soil will not. You can then filter the mixture to remove the soil. To do this, you set up a funnel with filter paper inside, which can drip into a beaker, and then pour the mixture into the filter paper. The water with the dissolved tea granules will pass straight through the filter paper, but the solid soil particles will be unable to. The soil which is left on the filter paper can be removed, washed with distilled water, and then dried to form pure soil. Sometimes you may need to remove a dissolved salt from a solution, such as copper 2 sulfate solution. To obtain the pure copper 2 sulfate salt from the solution, you use a technique called crystallization. In this method you use an evaporating dish over a water bath to heat the solution and evaporate the water. This water bath is made up of a beaker of water heated by a Bunsen burner using a tripod. The water bath heats the solution more gently than using a Bunsen burner directly. Using the water bath, you heat the solution in the evaporating dish until nearly all of the water has evaporated and small blue crystals of copper 2 sulfate begin to form. You now remove the evaporating dish and allow the rest of the water to evaporate naturally at room temperature. In this way, large crystals of copper 2 sulfate will form, and once all the water has evaporated, you are left with pure and dry copper 2 sulfate crystals. Distillation is used if you want to separate a liquid from a solution. This method separates liquids based on their boiling points. Using the crystallization method, we were able to separate the solid copper 2 sulfate from its solution. Using simple distillations, we are able to separate water from the copper 2 sulfate solution. The solution is heated in a flask which is connected to a condenser. As the water evaporates, it passes into this condenser, and in the condenser the water vapour is cooled so it turns back into a liquid. The water then drips into a beaker at the end of the condenser to be collected. The copper 2 sulfate solution remains in the flask being heated and is becoming more concentrated. Fractional distillation is used when you need to separate two or more liquids which are able to dissolve in each other. These liquids are described as miscible. An example of this is crude oil, which is a mixture of many different liquids. Each individual liquid has its own boiling temperature. Just like in simple distillation, the mixture is heated. Apart from the flask this time has a tall column attached, called a fractioning column. The fractioning column has many condensers connected at all different heights along the column. The column is the coolest at the top and the warmest at the bottom. As the liquids evaporate, the vapours rise up the column, where the temperature decreases. When the vapours reach the temperature at which they condense, they stop rising and enter a condenser, where the liquid is formed. The liquids are then collected individually. Paper chromatography is used to separate liquid mixtures, and it is often used to separate the components of dyes and inks. Paper chromatography works because some of the components in the mixture will dissolve better in the solvent being used. Firstly, you draw a horizontal line on a piece of chromatography paper with a pencil. On this line you evenly space out the dots of mixtures. You then place the paper in a suitable solvent, often in a beaker. The solvent level must not reach or go over the pencil line. The solvent will then travel up the paper, dissolving the mixtures and carry them up the paper as it travels. The most soluble components will travel furthest up the paper, and the least soluble components will only travel a short distance. Once the solvent has travelled to the top of the paper, or is no longer carrying any of the mixtures, remove the paper from the solvent and allow the paper to dry. The components of the mixtures have now been separated by their differing solubilities in the solvent. All these methods of separating mixtures are very useful for analytical work, where a mixture needs to be separated so that the components can be analysed.